Okay, today we're going to look at graphing quadratic functions, and we're going to be graphing them from vertex form. We want to look at some of the properties of vertex form. Alright, this is the equation in vertex form. F of x equals a times x minus h quantity squared plus k. And if you remember from transformations, a positive a, the graph is going to open up, and a negative a, the graph will open down. Another property of the vertex form is it gives us our vertex. A vertex is h, comma k. It also gives us the axis of symmetry. The axis of symmetry is x equals h, and you need to keep in mind that the axis of symmetry is a line, therefore it needs to be written in the form of a line. And when we graph parabola or quadratic function, I expect to see a total of 5 points. Some of the advantages for vertex form is, of course, it gives us a vertex. Okay, when we look at standard form, you're going to see why this one's an advantage. It also gives us the axis of symmetry. And we can look at vertex form and identify the transformations which have occurred to the parent. And again, it gives us the direction that our graph is going to open. If A is positive, the graph will open up. If A is negative, the graph is going to open down. Steps for graphing a quadratic function in vertex form. Of course, first you want to plot the vertex. Step number 2, you want to find 2 points on one side of the vertex using our parent table. Step number 3, you want to draw and use the axis of symmetry to complete the left side of the graph. And here's an example. First, we want to find the vertex. And remember, if we talk about inside grouping symbols and transformation, this is actually a movement to the left. So my vertex is -1, 3. The axis of symmetry is a vertical line that contains the vertex, so it's going to be our x-coordinate. So the axis of symmetry is x equals -1. My y-intercept, we're going to put 0 in for x. When I put 0 in for x, I'm going to calculate the y. So I have 1 squared times 2, which is 2, plus 3 is 5. So my y-intercept is 0, 5. The point symmetric to the y-intercept, which is a mirror image of our y-intercept across the axis of symmetry. So we'll get that when we plot our graph, and we'll also get the the x-intercept, excuse me, after we plot our graph. So let's go and let's plot our graph. So first I want to plot the vertex, -1, 3. I want to draw the axis of symmetry, and remember that is a vertical line going through our vertex. And we want to use the parent table to plot 3 points to the right of our axis of symmetry. Now, if you remember from our parent table, if I went over 1 to the right, I went up 1. If I go over 2, I go up 4. If I go over 3, I go up 9. And that's when our A value was 1. Well, our A value is equal to 2. And remember, that is a vertical stretch, which means it's going to change our y-coordinate. Well, it's going to affect it by upward movement. So when I go over 1, instead of going over 1, I'm going to multiply that 1 by 2, and I'm going to go up 2. I'm going back to my vertex. I'm going to go over 2, and based on the parent, we would go up 4, but since A is 2, I'm going to multiply by 2, and I'm going to go up 8. That's a little off my graph, but that's okay. We're going to go ahead and plot it there. And then the step said we're going to use the axis of symmetry and we're going to get those symmetric points and plot those. So this one point is 1 to the right. I have a point that's 1 to the left. This point is 2 to the right. I have a symmetrical point 2 to the left. I now have my 5 points, and I'm going to draw or connect those points with a smooth curve. Not a very good sketch of my parabola, but close enough. Alright, now we can complete our table over here. It said the point symmetric to the y-intercept. The y-intercept was here. The point that's the mirror image of that point is -2, 5. And our x-intercepts, it did not cross it, so we don't have any. And there's an example of how to graph quadratic formula using vertex form. And it's simple, and we'll do some more in class. See you tomorrow.